Today we are going to talk about the gases and the particles of those gases and how they behaved when we were in lab. So we're looking at the gas particles and what they did. Long time ago, scientists did very similar labs to what we have done with looking at the pressure and the volume, looking at pressure and number of particles, pressure and temperature, and they came up with an idea about what was going on with these particles, and we called that the kinetic molecular theory. And really all this is an idea of kinetic means moving, and we say molecular or the particles. So it's just the idea of moving particles. That is the kinetic molecular theory. So in lab, we looked at pressure and volume. And we saw that when one went up, like volume, when we made a bigger container, we saw the pressure go down. And then if we made a smaller container, the pressure went up. So these two are inversely related. So one goes up, the other goes down. Pressure is directly proportional to the number of particles. So we saw that if we added more particles, then the pressure went up. Or if we took some particles out, the pressure went down. So these, we have a relationship where they both go up or they both go down. Pressure is directly proportional to the temperature. So if we made things hotter, we saw that the pressure went up. If we made things cooler, we saw the pressure go down. To summarize, and I just want you to be familiar, I just want you to see this, the way that this is written. So this little symbol under here means proportional. So P is inversely proportional to volume. So we have 1 over volume. P is proportionally volume to N and T. So again, this little thing just means proportional. So looking at gaseous matter, or what we refer to as gas, we can come up with some key ideas to the theory. First, particles are in constant motion. They move in straight lines until they collide with something, and then they bounce back. So they're going until they hit something, and they bounce back. When they bounce, this collision that we have over here is elastic, meaning we don't lose any energy. It would be like a ball hitting a hard wall versus a ball hitting, say, a rubber wall or a mattress. So if you drop a ball on a tile floor, it's going to bounce back up, whereas if you bounce it on to the bed, it only bounces a little bit. It's lost energy when it hits the bed. Here, when we have that collision, it doesn't lose any energy. So as hard as it hits the wall, as hard as it's moving in this direction towards the wall, it will bounce back at the same force. And then they don't stick together. So if you've got two particles here and they collide and hit each other, we are not going to make them stick together. What we'll see, let's get rid of that one. What we will see is that they bounce off of each other, and they would go in separate directions. So temperature and pressure, when we're looking at kinetic molecular theory, we're looking at temperature, and we know is the speed of particles and how they move around. So temperature, when we're referring to the kinetic molecular theory, is the average energy, the average kinetic energy, or this is more like saying the average speed of all of the particles in a sample. Pressure of a gas is related to the frequency, so number of hits, and force of the collision of the gas particles. So we have number of hits and how hard of hits for the collision. Let's look at this back at temperature. So if we speed up the particles, what is going to happen to the pressure? Well, if we make them go faster, they are going to hit harder, and we will see that the pressure will go up. If we make them slower, so we lower the temperature and make them slower, they will hit less or not as hard, and we will see a reduced pressure. So that's how temperature and pressure are related. Frequency, well, if they're going faster, then they can move across the container quicker and they can hit more often. So that same particle can bounce back and forth 5 or 6 times when it's hot and moving fast versus hitting only a couple times if it was moving slower and was a colder particle. So temperature and pressure, that's their direct relationship. Alright, so on this whiteboard activity, what I would like to do and what I'm going to work through is the particle diagrams at each of these phases in our graph. So here at the beginning we have very few particles. Okay. And they're moving at a normal pace. So we have 3 particles and only 1 collision, and they've got quite a bit of room to move around in that container. At 2, we increase the number of particles, and we see that they collide a little bit more. By 3, we have many more particles, and we have more collisions with the side. So in a particle diagram, pressure is shown by collisions, so the little bounce. This point right here is the pressure. Temperature is shown by speed. Oh, here, I will write. Pressure is the collision. Temperature is the speed. Volume would be the size, and N would just be the number of dots.